Lesson 81, complex numbers and real numbers, products of complex conjugates, and division of complex numbers. All right, the first part dealing with complex numbers and real numbers is just review. All right, so as review, let's define a couple terms. All right, first of all, a complex number. All right, we know that a complex number is a number that has a real part and an imaginary part. All right, so when we're dealing with complex numbers, we're dealing with an imaginary number. Those are those dreaded I numbers, all right? When we write a number that is complex, we write it in what is called standard form. And keep in mind, in standard form, real number is written first. All right. All right, so a complex number is a number that has a real part and an imaginary part. When we write the real number first, it's written in standard form. Now, we're going to be dealing with division of complex numbers. But first of all, let's talk about products of complex conjugates. All right, a conjugate, we already talked about conjugate pairs when we talked about radicals. And remember, when we have a conjugate pair, if we have a term, going back to radicals, in order to write 4 plus root 3's conjugate pair, we would write it as 4 minus root 3. All right, the same thing goes for complex numbers. All right, if I had 4 plus I, the conjugate pair of 4 plus I would be 4 minus I. All right, so we're dealing more, again, with conjugate pairs. All right, and just like radicals, imaginary numbers cannot be in the denominator of any problem. Okay, so we're going to have to multiply by a conjugate pair to get rid of any imaginary number in the denominator, just like we had to get rid of any root in the denominator. All right. When we talked about products of complex conjugates, when we multiplied, if you remember, I mentioned that when you are multiplying the conjugate pair in the denominator, the only thing you need to multiply is the first term and the last term, because those middle terms will cancel each other out. The same thing goes for multiplying complex conjugates. All right, so we're going to do just a few examples, and this goes under the category of division of complex numbers. All right, so in dealing with division of complex numbers, all right, multiply both the numerator and the denominator by the conjugate pair. All right, so same thing that we did for radicals. We're going to multiply both the numerator and the denominator by the conjugate pair. All right, let's look at an example. All right. We have 2 plus 3i over 4 minus 2i. All right, again, we cannot have a radical in the denominator, so we're going to have to multiply through by the conjugate pair. Well, the conjugate pair of 4 minus 2i would be 4 plus 2i. So we're going to multiply both the numerator and the denominator by 4 plus 2i. All right, this means that we're going to have to distribute. All right, so let's look at the top first. 2 times 4 gives me 8. 2 times 2i gives me 4i. 3i times 4 gives me 12i. And 3i times 2i gives me 6i squared. All right, keep in mind in the denominator, same thing goes as when we did radicals. You only need to multiply the first terms and the last terms because the middle terms will essentially cancel each other out. Now, if you want to go ahead and multiply those middle terms to make sure you're doing it right, feel free. All right, but we just multiply the first term, so 4 times 4, which is 16, and the last term, negative 2i times positive 2i, which will give me, negative 4i squared. All right, now we just need to simplify. Now keep in mind, I squared is the same thing as negative 1. So here in the top term, I'm really doing 6 times negative 1, which would give me minus 6. And down here, negative 4 times I squared would actually end up giving me plus 4. All right, so if I combine like terms in the top, I have 8 minus 6, which is 2. 4i plus 12i is 16i. And then 16 plus 4 is 20. 2 goes into each of those terms, so I'm going to end up with 1 plus 8i all over 10, and that is the final solution. All right, just like multiplying radical conjugate pairs. All right, let's go ahead and look at another example. All right, we have 4 minus 2i over 2i minus 3. All right, again, in order to get rid of that radical in the denominator, we need to multiply through by the conjugate pair. All right, the conjugate pair of 2i minus 3 is 2i plus 3. And then we just need to distribute our way through. All right, so here, 4 times 2i gives me 8i. 4 times 3 gives me 12. Negative 2i times positive 2i gives me negative 4i squared. And negative 2i times 3 gives me negative 6i. And on the denominator, we just need to do first and last terms. So we have 2i times 2i, which gives me 4i squared. And we have negative 3 times positive 3, which gives me negative 9. All right, again, we need to go through and simplify. All right, I squared is the same thing as negative 1. All right, so if I multiply negative 4 times negative 1, that's going to give me plus 4. Down here on the bottom, 4 times negative 1 gives me negative 4. All right, so this is what I'm left with. 8i plus 12 plus 4 minus 6i all over negative 4 minus 9. And then we just combine like terms. 8i and 6i is 2i. 12 and 4 is 16. I'm going to put that in the front so that we are keeping it in standard form. All right, and then negative 4 plus negative 9 gives me negative 13. And that is the final answer since nothing can be simplified. All right, I'm going to go ahead and give you 2 examples just to work out on your own. Go ahead and finish these, and we will check them when we come back into class. All right, the first one is 2 plus 3i over 3 minus 3i. And the last one is 2 minus 2i over 2i minus 2. All right, so go ahead and try those 2 on your own, and we will check them when we come back into class.